Hello, are you guys there? Can you guys hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So you guys don't have a question or anything?
Yeah, naman, sir.
So how many are we now? So 70. So can you guys recall how many participants do we have last meeting?
19 na ata, sir.
19. Alright, so this one is already close enough. Anyway, so the others who are still planning to join, then they'll just catch up to us. Alright, so let us now proceed or start with our discussion for today. So for today's topic is the language of mathematics. Okay, and then here are the topics covered for this module. So we'll talk about sets, sequences and strings, relations, equivalence relations, matrices of relations, and then lastly is functions. Okay, and to those who are already finished with your Math 100, so this one is super familiar, like 80%. We have already discussed 80% of these topics in here. So this one is super easy already for you guys since this one is just like, recalling only the topics that we have finished in Math 100. All right, so to begin with, we will start with set. So what is set? So it is any well-defined and unordered collection of objects called elements or member of the set. So when we see well-defined, it is possible to decide if a given object belongs to the collection or not, meaning we can distinguish that this one is really under the set or no. Okay, so it is described by listing all of the elements of the set between braces. So we have examples here. So this one is a set, this one is also a set, and then another one or the last one is also a set. So from here we have three elements wherein it's 11, 12, and then 13. Okay, this one is one set. The other one is composed of pictures wherein we have here an, I don't know what for this is what. Maybe this is an apple, a banana, and then a grapes. And then the last one is composed of mixed uh, elements. We have pictures or let's say fruits, and then we have number, and then we have word. Okay, so a set can be anything. Okay, so it can contain anything. All right. So the one that is inside of our set of our bracket are called elements, right? So they are the member of that certain set. Okay. So we have here notation. So this is the symbol for notation, wherein this one is called the epsilon. So this one is used to denote an element of a set. So we have the other one wherein it has a slash on it. This one denotes that the object is not an element. Okay, so element, not an element, right? So we have an example here. 3 is an element of S. So S here is a set. It's just a variable S wherein it has an element of 3. So 3 is an element of the set S. So another example here is we have a set of all positive integers less than 4. So we have here a set and then another set wherein those sets are said to be set of all positive integers that is less than 4. So we have letter A wherein 1, 2, 3, wherein this set is less than 4. Okay, so it says here order is not important. So you can arrange this in any matter that you want. So it could be 3, 2, 1, 2, 1, 3, 1, 3, 2, or whatever, right? And then we have another, okay, set here, but in it has an element of 1, 2, 1, 2, 3. Okay, so this one is just the same with letter A. Why? Because in a set, okay, it any repeated elements, okay, can be eliminated. Okay, so if there is already one existing distinguished element on that set, then the others that is the same with that element can be eliminated. Or simply in a set, there should be one distinguished element only. Okay, so in here we have 1, 2, 1, 2, 3. Okay, so 1 and 2 is repeated, so you can just basically remove that one. Okay, so it doesn't matter how many same elements inside of a set. Okay, what we are trying to count inside of a set is the distinguished elements only. Okay, so in here we will just include 1, 2, and 3. So no matter how many 2, how many 1, or how many 3s. Okay, so this one is just the same with set letter A. Right? Right, so next we have here the basic properties of sets. So sets are inherently unordered. Okay, just like I have said a while ago. So arrangement doesn't matter. So it could be ABC, ACB, BAC, BCA, CAB, or CBA. Those arrangement or those ordered are just the same. Okay, so it can be any format. So all elements are distinct or unequal, just like what I'm trying to say a while ago with this repeated elements. So one distinct element only, and then the rest, which is the same, can be eliminated. So multiple listings make no difference. So if A is equal to B, then ABC is also equal to AC because A and B has the same value. Okay, the same with this one. BC is also equal with AC because again, B is equal with your A. Okay, or this one is also equal with AA, BA, BC, CCC. Okay, so if you're going to uh, analyze those sets, so those set contains at most 2 elements only. Okay, considering that A is equal to B. Okay, even though they have different names of variables, but they are equal in terms of value. So we could simplify that A only or B only. Okay. So can you guys follow so far?
Yes, sir.
Yes, sir.
All right. So if ever that you have a question or clarification, so please, please ask a question right away. Okay. All right. So let's proceed. So let's have an example in here. So number one, the set of V of all vowels in the English alphabet can be written as. So who wants to answer this one? Anyone? We have set B. Okay, so all you need to do is indicate all the possible elements of this set B.
Hey, how you?
So what is the first thing that we need to do?
List the vowels in the English alphabets.
Just list all of the
The vowels in the English alphabets.
vowel alphabets. Oops. Yeah, that's right. But of course, you have to make a bracket first, and then just list or start listing now the vowels English alphabet. So what are those vowels? So we have letter A, E, I, O, and then okay. So A, E, O. Okay. And then what is the name of this set? So it's letter or capital letter V, which is equal to this set. All right. So this one is the answer for the number one. How about number two? The set O of odd positive integers less than 10 can be expressed by. So we have set O. So what are those odd positive integers which is less than 10?
379.
1, 3, 5, 7, 9.
1, 3, 5, 7, and then 9. All right, very good. How about number 3? So we have set Z. And then says here that set Z of positive integers less than 100.
1 to 99.
1 to 99.
1 to 99. So you can list 1, 2, 3 first, and then that, and then up to 99, right? Okay, so you can do this one, meaning this one is incrementing by 1 just by showing the 1, 2, and 3, and then up to 99 only. All right. Right, so very good. Next example. So if A, or if set A is equal to 1, 2, 3 elements, can be written as, so this one has an element of 2, okay, or this A has an element of 2, or you read this one, 2 is an element of A, okay, or 4 is not an element of A. So 4 is not really an element of A because 4 is not in here, okay, so simple as that. And then also, this one is different with each other. So 1 and a bracket and then 1 inside is different with this number 1, okay? So this one is just a number, but the other one, okay, with a bracket, okay, is a set. So again, a set always starts with a bracket or a curly bracket. So if there is a curly bracket on that one, okay, let's say an empty curly bracket, this one is still a set, okay, regardless of, not having an element. This one is called an empty set. So later on, we will discuss this one. But for now, we will focus on this one. So for now, just take note that this is not the same with number 1. Okay. So similarly with this one is a set which contains 1. It's different from a set which contains another set. And then that set contains 1. Okay. And then, so this is the explanation. So for 1, or for a set that contains 1, so 1 is an element of 1, but this set with 1 is not an element of set with 1. So they are completely different. Okay. So the element of this one is actually a bracket or a double bracket 1. Okay. So this is the second explanation for this double bracket. So for the second one, so we have a bracket with 1. So this is the element of this set, okay, coming from these entire 2 double brackets. But 1 is not an element of this double bracket 1. All right. So you have to remove the bracket before you could see that that one is an element of that certain set. Okay. So in here, you have to take note also the counts of the bracket before you could see that this one is an element of that certain set. Okay. So that's the explanation and why they are not equal with each other. Okay. So set 1, 2 has 2 elements, but this one, wherein we have double bracket, this one has only 1 element. Okay. So in here, we don't care how many elements inside of that double bracket. Okay, so what we're only trying to consider is the first bracket that we have in here. Okay, so take note on that one. Okay, if we have double curly brackets, that one is just composed of 1 element. So you guys will see more examples regarding with this double curly bracket. Right, so for now, let's discuss this set builder notation. So for any proposition X over any universe of discourse. So we have this kind of expression wherein a set is an element of X such that a proposition X. Okay, so if you will see this kind of vertical line, we read this one as such that. Okay, so you could say that this is a set wherein X is a variable such that proposition X. Okay, so this can be derived by specifying a property that the element of the set have in common. So for example, number 1. So X is an element of positive integer wherein X is less than 4. So this X in here has in common with this condition wherein we're saying that this X is only less than 4. Okay, so the same with this one. So this X is related with this one or with our condition. So X is a letter in the word bite. Okay, so you will get this one once you've learned bytes, bits, letter, word, and so on and so forth. Okay. Anyway, we're just trying to say that this one is connected with our condition or with our uh, proposition. Okay. So we have here notations used. So just take note on the variables given in here. So these are the special variables, wherein Z plus is indicating that this one is a set of positive integers. Okay, like 1, 2, 3, and above. Okay, that's why we call that one positive integers. And then n, okay, this one is a positive integer or 0, or just simply natural numbers. Okay, so in here, this one is also like a positive integers, but you have to include the 0. Okay, and then for z only, this one is an integer, wherein it covers, of course, the negative, the positive, and then, of course, the 0 also. And then for q, we have here rational number, wherein this one is a fraction. So as you can see, we have two variables here, wherein p must only or must be an element of the integer, and that q is also should be an element of the integer, but not, or let's say, yeah, it can be anything, but the denominator should not be 0. Okay, so that's the only limitation, because if you're going to put here 0, then that's math error. Okay, so it could be anything, or it could be any integer aside from 0 for the denominator. Okay, or you can have this another format wherein a divided by b, wherein b should not be equal to 0. Okay, or the denominator should not be equal to 0. Okay, and then the last one is R, which is composed of real numbers. Okay, what is real number again? Anyone?
Sir, lahat ng numbers.
So all of the numbers that you can think of. Okay, be irrational or rational numbers. All right, so let's now talk about empty set. So this one, so from the word itself, empty set, this one has no element. Okay, so this can be written as just by simply, having a double, or this one, a curly bracket. And then the last one is this 0, wherein it has a slash on the middle. So this one is representing empty set. This one is also representing empty set. But in other terms, we call this one null set. So basically, when you're going to analyze empty and then null is like, no value, and then empty doesn't contains anything. So you can say that they are equal in terms of definition. Okay, so we have an example here. X is an element of real number, and x squared is equal to -1. So here's the condition. So you can put any value of x in here as long as you could make it equal with -1. So can you find that value of x? Wherein if you're going to replace this one, you'll get -1. Anyone? Can you guys think of a number?
No, there's no number.
There is no number. So as you can see right here, number 1 is an empty set, because we're gonna think of a number or an x value wherein it can make it equal to -1. So in here, set R is an empty set, or it doesn't contain any values for x. Okay. The same for number 2. Can you guys think of a real number that would make it equal with each other? If ever you're going to replace this x by a number. Is there a number?
No, sir.
So as you can see, number 2 is also an empty set. Okay. So if you're going to replace here, let's say x into 1, so 1 on the left side, and then 1, and then plus 1 on the right side. So of course, they are not equal anymore. Okay. So no matter what is the number that you're going to replace for the x, it will not be always equal. So it's always bigger on the right side than the left side. All right, so that's it for the empty set. So after that, you're going to have a seed break. So don't worry, this one is super easy. All you do is verify this one if it's or true or false. Okay, so there's a total of 6 numbers. All right, so I will leave this one into you, and then I'll just inform you guys once your canvas is updated, and then you can now start answering this one on your canvas. All right, so I'll give you guys 10 seconds to take a look on your zip break. So do you guys have any clarification or concern so far?
None, sir.
None. All right. Okay, so oops. Oh, another zip break. So this one is listing the elements. Okay, so list the elements of the given set. So this one is similar with what we did a while ago. Okay, like this one. And then another one is write the set of letters in each word by listing elements of the set. Okay, so we have here 3 numbers for the for this set break. Right. So again, I'll give you guys 10 to 15 seconds to check on this one if ever that there is clarification or uh, misunderstandings regarding with the instruction. So if there is no name of the set that is being declared, so you don't need to assign a name of that certain set. So just list all of the elements. Okay. So you can start with curly bracket and then just put the uh, elements inside of it. No need to assign a name of that set. So any concern?
Wala, sir.
None. All right. So if ever that you have a clarification, so feel free to ask me anytime on my Canvas or to my Facebook account. Okay. All right. So next we have here equal sets. So this one is 2 sets are equal if and only if they both have the same elements. So this can be written as A is equal to B. So take note, this one contains or it has its own value, and then this one also has its own value. Okay. So if ever that we have the same content or same elements, then we could see that A is equal to B. So we have an example here. Number 1, if A is equal to 1, 2, 3, and then B is having this kind of format. So X is an element of Z plus. So what is Z plus again? So this one is set of all positive integers. And then X squared is less than 12. Okay. So if you're going to take a look at this one, if ever you're going to analyze letter B, so you will only come up with 1, 2, and 3. Okay, because our condition is if you're going to square that x, so 3 squared is 9. 4 squared is 16, which is already more than 12. So that is why 1 to 3 only, or positive 1 to 3 only for letter B. So in here, we could see that letter A is equal to letter B. Okay, or set A is equal to set B. Okay, so the same with number 2. If A is equal to basic, Pascal, and then ADA, and then B is in a form of ADA, basic, and then Pascal. So as you can see, they have the same content. It's just that in a different arrangement. So again, in a set, so it could be an unordered list. Okay, so arrangement doesn't matter in a set. So in here, we can say that A is equal to B. All right. And then for number 3, we have here 1, 2, 3, 4. Okay, this is already a set. And then it is saying that this one is equal with, so X is an element of Z, where X is greater than 0 and X is less than 5. So if you're going to form the list of elements of this right side expression, then of course, you're going to start with 1 since we have a requirement or a condition here wherein it should be greater than 0. And then you will stop with number 4 because it is saying here that x is less than 5, which is of course 4. So it is incrementing by 1, so 1, 2, 3, and 4. So from here, we could say that this left side expression is equal to the right side expression. Are we clear so far?
Yes, sir.
Yes, sir.
That's good then. All right. So next one is subset of a set. So when we say subset, okay, meaning that set is under a certain set. Okay, that's the simplest definition when we see subset. And then here's a symbol for a subset. So we have here the definition. So every element of A is also an element of B. So meaning this set A is under set B. Or we could say that this set A contains also all of the possible elements on set B. Okay, that is if X is an element of A and all X is an element of B. Okay, then A is a subset of B, or A is contained in B, or can be written as like this. So the left side is the lesser element, wherein whatever is the element of this left side can be found on your right side set. Okay, or you can write this one as universal X. So for all X, so we have already discussed the universal and then existential. So as of by now, you should already know what is this one. So for all X, X is an element of A. Sorry, forgot to put the if since this one is conditional. So if X is an element of A, then X is also an element of B. Okay. Well, this is just another way of saying that A is under B or A is a subset of B. Okay. We will not use this one. This is just another approach. So the one that we're going to use is this one. So this one is a lot simpler. Okay. So if A is not a subset of B, then we can write that A and then a subset symbol with a slash on it. Meaning this one is not a subset of set B. Okay. So let's have more examples so that you can understand what is this subset. So we have here example set A wherein it contains elements 1, 2, 3, 4, 5, 6, and then set B wherein it contains 2, 4, 5, and then set C is contain an element of 1, 2, 4, 5. All right, so from here we could say that set B is a subset of set A. Why? Because this element 2, 4, 5 can be found on our set A. So 2, 4, and 5. All right, so our right side expression or right side set is like our mother or our father. So all of the features that we have right now came from them. Okay, so they're like the creator. Okay, but some of the features that they have maybe doesn't or we doesn't have it. Okay, something like that. And then we could say that B is also a subset of C. Why? Because 2, 4, 5 can also be found on set C, which is this 2, 4, 5. And then set C is also a subset of set A, wherein 1, 2, 4, 5 can be also found on set A. So 1, 2, 4, and then 5. And then lastly, so A is a subset of A, B is a subset of B, C is a subset of C. So meaning every set is a subset of itself. And of course, yourself can be a subset of yourself because anything that you have is in you, okay, can be found in you. Okay, like for example, this one, 1, 2, 3, 4, 5, 6 can be found in yourself, which is 1, 2, 3, 4, 5, 6. So that is why every set is a subset of itself. Okay, so were you guys able to follow?
Yes, sir.
Yes, sir.
Yes, sir.
Right.
Yes, sir.
Okay, next one is Venn diagram. So most of you already know this one. So it is used to show the relationship between sets. So it is named after the British logician John Venn. Okay, so maybe he's the one who created what is this Venn diagram. Okay, so as you can see right here, we have this blue circle wherein this one is set B, and then we have a smaller circle wherein this one is set A. So from here, you could say that set A is a subset of set B because all of the elements of set A is under set B, right? And then the other one is A is not a subset of B. Why? Because, only some of them are equal with each other, or B have maybe a common with A, and then A have a common in B. But there is no one wherein in a total domination or all of the elements of A can be found on B or vice versa. So you cannot find that requirements on a subset for this one. So that is why A is not a subset of B. Okay, so that's it for Venn diagram. So we have here more examples for subsets. So what are the subsets of set A1, 2, 3? So we have here the solution. So first, you can write empty set is a subset of A because initially, of course, we have here an empty, okay, or empty slats, which is now this one. And then you can now start putting the elements of the set A. So set 1, or this set, which contains 1, is a subset of A. 2 is a subset of A. 3 is a subset of A. 1, 2 is a subset of A. 1, 3 is a subset of A. 2, 3 is a subset of A. 1, 2, 3 is a subset of A. Or A is a subset of A. Okay. So basically, anything that is inside of this A can be a subset of this set, as long as that element can be found on that set. Right? So were you guys able to get this one?
Yes, sir.
All right, it's good then. Okay, let's have another example. So let A and empty be a set. Meaning, so again, just like what I have said a while ago, in any set, there is already an existing empty set, okay, initially. Okay, so that is why empty set is a subset of A. And then if A is a subset of B and B is a subset of A, then we could say that A is equal to B. So if this is the case, wherein it could be a subset of uh, different variables or different sets, rather, we call this one a proper subset. Okay, so A is a proper subset of B, which is denoted by A proper subset B. So the only difference for this subset here is this one, the symbol, which is a horizontal line on the bottom. So for the proper subset, doesn't have a horizontal line on the bottom. So this one is called the proper subset. Okay. So yeah, that's it for the subset and then proper subset. And then later on, we will discuss what is this power set. So for now, we will stop right here since we don't have enough time anymore. So I will stop this meeting now and then just see you guys on the part 2. Okay, so just wait for my second link. Right, so goodbye for now. I'm ending this
Thank you,
meeting.
sir. Goodbye.
Thank you. Goodbye.